journals is nothing but it's a data protection method. So if you take like Oracle or DB2 or anything, so whatever we do DML operations, at the end of the DML operations, we do have DDL is auto commit in Oracle, but in DML statement is user commit. So we have to commit it, then it will be committed. Okay. So if you are doing something, it will be rolled back. So if you have committed some mistake, we can roll back. But in Teradata, we have the concept of journals. Okay. We don't have in Teradata mode, as we said, so everything is auto commit. Right. So in Teradata mode, so everything is like auto commit. So if in order to maintain the data integrity, we need to go for the journals. Okay, like a data backup. So all those we need to go for journals. So journals are is nothing but, so if we are, it's like a data protection method. If you are anything happened on software or hardware, so for example, you are inserting the data or you are updating the data or you are deleting the data. So if you are doing any operations, if anything has AMP failure or anything happened failure, then if you, in order to maintain that data integrity, we need to roll back or like undo or redo operations. We need to do that. Okay. So journals is like nothing but we are like a book we are writing, right? So we are taking some Xerox copy image, right? For example, before updating the front page of the book, you are going to take a Xerox copy of the book so that it will be, the previous state will be maintained. So if anything goes wrong on the whatever you are going to update on the page, you make use of the previous page you have taken. Okay. If you are comfortable that whatever the Xerox copy you have taken, you can discard it. The same way here in Teradata, we have like any interrupted transactions. Okay. So if you have any interrupted transaction or any failure, hardware or software failure, this journals will be taken care. Okay. Takes place automatically. There are three types of journals are there. Okay. Three types of journals are there. So whenever you are creating a table, okay, so you have to mention this journal. Okay. The first one is like transient journal. Transient in the meaning like it's for a short time. Okay, for a short time it will be maintained. And we have permanent journal and we have down amp recovery journal. Okay, DAR, we will call it as DAR. So there are three types of journal. First we will see that transient journal. So transient journal is maintained by system. We are not handling it. It will be maintained by system. So we don't have any control. The system will take care of this operations. Okay. By default, it will take on the database level. Okay. So for example, if you are doing any operations, like you are doing inserting a record or updating a record. Okay. So you are doing some transactions. You assume that you are doing some transactional data. You are sending money to other bank or other account. NiC. So on one particular bank. Okay. So it needs like a debit from your account and credit to the account. Okay. So it has been debited in your account. Assume that. But before crediting to that account, the another account, so the transaction has been failed. So what you need to do? So the Teradata needs to take care that it should reverse that operations, that whatever the amount has been debited from your account, it should be to the reversal operations. Okay. So for that, if anything goes wrong, the same way, if you are going to update or insert or any delete on any table, so if it is going to, so if anything goes wrong, it should be undo. Okay, it should be undo on the previous state. So transient journal is nothing but it will be system will be maintained. It will be a short period of time. Okay. The next one is called down amp recovery journal. Okay, this is also system will maintain. So whenever you are maintaining a fallback table, right? Fallback. So you know, right? Fallback. So fallback means, so it's like AMP level failure. If you are enabling that fallback, then if any one of the AMP has been failed, the recovery will be maintained in the another AMP to the image, like another image. It is called down AMP recovery journal. Okay, so another AMP, it will be maintained, the recovery. So this is also maintained by system whenever you are enabling fallback.
No,
Okay,
fallback.
fallback. Transient journal, it will be automatically enabled. You are not going to enable it. And we have like a permanent journal. Permanent journal, it will be permanent. So transient journal, it will be short period of time, it will be available. If your transaction is getting success, then whatever the journal has taken, right, it will be vanished. Okay, it will be vanished. Or your transaction got failed, it will be replaced with that, it will be undo to the particular the previous status, and then after doing that undo, that whatever that the journal it has taken, right, it will be vanished. Okay, anyhow it will not keep after the transaction failure or success. Okay, but for permanent journal it will be kept in the system, the permanent space. So user has to enable it. For example, you are going to use this journaling for the very sensitive data. Okay, balance or transaction tables. These tables are very sensitive table. Why? Because the balance will be maintained. Okay, so account holders balance will be maintained on this table. So if anything goes wrong in this table, then it will be very difficult to recover it, right? So whatever, so we are going to do any changes, whatever the changes happened for the table level. So it's like balance is getting impacted table level. So at the time of impact, we are going to take the every time, okay, whatever that it is getting changed, every time we are going to take the snapshot, the previous state of the row level or record level or table level.
So while creating the label,
Yeah, we have to enable it. This permanent journal, we have to enable it. It will be permanently available in the database in real time, right? In our real time, the purging will be happened. Purge, purging will be happened. So the permanent journal should be purged. So at some particular time, like 1 hour, 6 months once, they will purge. Whichever the journal has been taken, uh, like after 6 months, before 6 months, it will be purging. So this is what the three types of journal which is available in Teradata. And also we have two types of images. One is before image, and another one is after image. Before image means, for example, you are going to update some record. Okay, you are going to update some record. Before updating it, you are taking some image snapshot. So that will be your before image. For the rollback or undo operations can be done by using the before image. After image means after you are updating, what will be the new data, before data, after data. So redo. So whenever instead of undo we want to do the redo operations, you can go for the after image. So these two are the two types of images are available in this Teradata. So journals like a transient journal, I explained, right, what is transient journal. So transient journal is a system journal. Okay, right? It's a system journal. So assume that it provides transaction integrity. Transaction integrity is in the sense like whenever there is a failure or something happened, okay, then it should go for the previous state. Okay, that will be a transient journal. Transient is nothing but for a short period. Okay, and also before image is kept on the AMP. So each and every AMP, the before image will be kept AMP level. So once that the successful or failure transaction happened, it will be vanished. So in case of failure, okay, in case of failure, if you see here, so we are beginning the transaction. So we are updating row A, updating a row B. So while updating a row A, before image will be taken. Okay, before image will be taken. So before updating a row B, we are taking the before image. You assume that there is a failure while updating the row number B. These two are same transaction. These two are same, one single batch we are running it. So if anything goes wrong in one particular failure, then both the cases it will be rolled back. So both the cases will be rolled back. So this is called it will be rolled back to before. Okay, in case of a failure transaction, the data reverted as per the before image. So as per the before image, it will be rolled back. After rolled back, whatever the image it has taken, right, it will be discarded. It will be vanished. In case of successful, update row A. You are updating a row A. Before image will be taken.
Updating will be.
Okay, before image will be taken. Whatever the table you are taking, right? Before image will be taken. So you are updating so many records. Okay, updating a row B, something you are updating it. After that, so after updating everything, the transaction has been ended. So it has taken some images, right? It has taken some images. That image will be discarded. Why? Because there is no use of that image. That before journal there is no usage, right? Why? Because the transaction got success. So with that you are not going to use it. So anyhow, it is a success or failure, it will be discarded. But if it is a failure, it will be used. In case of success, it will not be used. So after this rollback operation, the before image are deleted. Clear? For a successful transaction, the transient journal is cleaned after a commit. Even success also, it will be deleted. So every AMP has a transient journal. Every AMP has a transient journal that will be maintained in the DBC's permanent space. So permanent space only it will be maintained. After that success or failure, it will be vanished. That's all. It will not kept permanently. This is what the transient journal. Transient means short period of time. It will not be permanent. So next one is like down amp recovery journal. So what is that down amp recovery journal? This is also system journal. System maintained. So as I told, whenever you are enabling fallback table, the image will be taken in the another amp. Okay. So down amp recovery journal allows continued system operation when one amp is down. So it will be the image will be maintained by another amp in the same cluster. So like multiple amp is there, that is called a cluster. So down amp recovery journals are applicable for tables created with fallback. So whenever you are creating a table with
Then where will be the AMPs will be found through this primary index after a hash algorithm?
No. Whenever you are creating the table with the fallback, the down amp recovery journal will be created. So you are not going to use. So even you are using primary index or not primary index, no issues. So whenever you are creating a table, I told right, in every amp the table will be created. So the copy of the table structure will be created. Okay, whenever you are creating a table, in every amp the table structure will be created. Whatever the data you are going to insert it will be inserted on the particular amp, on the particular disk. So why? Because every amp it has its own structure. So that is what. So if you are creating a table with fallback, so if the table structure has been created in one amp, right? So the recovery journal will be created on the other amp, the image. When we have seen that concept of like fallback cluster. So that is the called fallback. Okay, it is called fallback. So you have to create a table with fallback. So this is what you have to mention. So whenever you are creating a table with fallback, so automatically the down amp recovery journal will be created. No need to create by user. So transient journal, it will automatically created whenever you are creating a table. So you are not explicitly maintaining any method. But this after no before journal, after before journal, dual journal and all, it is the permanent journal. Okay, so this is like where one amp is getting failure, the data will be maintained in the other amp. So we have seen that operations, right? So this is what the down amp recovery journal. Next one is like permanent journal. Permanent journal, we have three options. One is like this is the user level journal, so which is used to protect the data, and also it has three images. One is before image, after image, dual image. The purpose of permanent journal is to maintain sequential history of all changes made to the users. For example, if you take your banking account, okay, banking account. So you are doing some transactions like credit, debit, so many transactions you are doing, but you want to see that what is the your balance like a 10 days before. So how your record is before 10 days, then if they have enabled the permanent journal, it will be available. So 10 previous transaction you can go to the state. So that is what. So but it will occupy more space. So permanent journal has protect the user data when user commit, uncommit, about any transaction, it will be maintained. So whenever you are doing commit, right, so it will be taken on image. So uncommit, so you are not doing anything, so you are so you have some failure has happened, so it will take on image. About the transaction, it will take on image. So whenever there is a change the data, it will take on image. So that image will be maintained for the like data integrity. Okay, sequential history will be maintained. Okay. So it will capture the image like a before and after, before a change, after a change, and both. Like it will be a like before journal, after journal, dual journal. So dual journal means so like a dual copy of the it will take. So when you create a new journal table, you can use several options to control the types of information. Okay, for example, you are creating one table. You can mention like before journal, okay, before journal or after journal, dual before journal, dual after journal. So what it does mean? Before journal means before update or insert or anything happen, it will take one image. After journal means after creating that
After
whatever you are
automation.
updating, it will take one image. Dual means it will take two copy of before journal. Two images it will take. So we are taking some two Xerox copy of one particular document, right? So
Okay.
we will kept it in somewhere. So it should not, it's very sensitive. Then we will take two copy. So something goes on one copy also, it will be available one copy. So that is why it is very sensitive data. You can go for dual before or dual
Before
dual after.
dual
So you
after.
have to enable
Okay.
it whenever you are creating the table. But you must allocate sufficient permanent space. As I told, whenever you are enabling
Yes,
that
yes.
before journal or after journal, you have to the space is utilized more. This is what
Yes.
permanent journal everything. So before journal means it stores an image. You are clear, right? Stores an image of a table before it changes. Specific point of time. So whatever some error happening, it will specific point of time. So sequential of operations. Okay, it has done like hundreds of commits, hundreds of changes. All the hundreds of changes it will be taken images. This captures two images of a table before it changes. Okay, duplicate images on the two different AMP. If one AMP is failure, the other AMP also will have that
Other
duplicate image. So you are having one AMP, okay, one AMP that data is there. So the image will be created on two different AMP. So this AMP failure, the data is there in two different AMP. So that is what the data integrity will be maintained. So remember, the permanent journal must be manually deleted. Okay, manually deleted some point of time. So these are all the journaling concept. So
Okay.
whenever you are creating the table, you have to mention in your journal. So next one, we are having the locking system. Okay, locking. So next one is called locking mechanism. Okay. So this locking mechanism in real time it will be very much important, and also the Teradata will also take care of that locking mechanism by default. Okay.
Mhm.
So like whenever locking mechanism is not nothing but it's a data integrity. Okay, in order to maintain the data integrity, we are going for the locking system. For example, if we are working in a multi-user environment on the same project, same team, same applications, so multiple user will be working on the same table, right?
Mhm.
Same database. They'll be updating it. So all the data integration, sorry, all the data updation, deletion, insertion, they will do it. Okay, in the same table. So for example, if we are working on a multiple user environment, if I am doing some update on the table, so I should not allow others to update on the same time, correct? For that, Teradata will automatically go for the locking. If I am updating the record, okay, on the table, so others on the same time they cannot update it. Okay, why?
Okay.
Because it will not maintain data integrity. Okay, so for example, you are maintaining like you have mentioned like update table name, set this value where country equal to India. Okay, you assume that you are thinking that country equal to India. I am updating for that India. I am going to update as USA. So another person has update statement where country equal to India. It has some record at the time, but I am going to update like update table name where country equal to USA, then all the India will be updated as USA. Then when the other person is trying to update it, it will not be updated. It will not maintain the data integrity. right? There will be no record. So, and also might be like data loss also happen. So to avoid this kind of scenario, we are going for the locking mechanism. Okay. So we have four types of locks. One is like exclusive lock, write lock, read lock, and access lock. Okay. So temporary locks can be placed. It's not permanent. Okay. It's a temporary lock can be placed on a data to prevent multiple users from a simultaneous access. So there are four types of access. One is exclusive lock, write lock, read lock, and access lock. Access lock, we will call it as dirty lock. I will tell you why we are calling it dirty lock. I will tell you. There are four types of lock: exclusive, write, read, and access lock. For example, first we will let us see that read lock. What is that read lock? You have one table, product table or transaction table. You are using that select star from the table. Okay, select star from the table. You are reading the record from the table. So while reading the data, so can I allow others to write the data? I'm reading the data. Can I allow other user to write the data the same time? So if I'm reading the data for one
Should not.
reports, so same time can I allow other user to write the data? If I do
No.
not want to write the data, then I have to go for read log. If the object is on the read log, the other person cannot write it. Other person cannot write it. Why? Because I have meant for read log. I put it on the read log. So if I put read log, can other user can read the data? If I logged a table for the read log, read log, can I allow
Yes,
other
others
user to
can.
read it? Yes, I can
Yeah,
allow other user to read the log
everyone
data,
can
so
read.
everyone can read. So in case of if I'm the read log, if I didn't put the read log, if other so I'm using the select star from the table, it has been executed at the same time. The other person is updating it. So whatever the data I'm seeing, whatever he is updating, it will not be matched. The data will not be at the same, right? Sometimes. So that is why the read and write log are not compatible with each other. Okay. If you have enabled write log, you cannot read it. If you have read log, then you cannot write it. So both are not compatible. Okay. If I go for write log, you assume that write log. So if I'm insert, update, delete operations I'm performing, if I'm going for write log, at the same time I cannot allow for read. If I'm writing it, then they cannot. If they're seeing it, it will be data integrity. They will not see the consistency on the data, right?
Yes.
They will not see the actual data. Some error or some the other data might be seeing it. Okay. So for example, you are updating the data or loading the data, it will say like the data is being loaded. So if you are loading the data, at the same time you are going for select start from the table, it will say like the table is getting loaded, the being loaded. You will be getting that particular message. That will be a write log. The database by default will go for the write log. Whenever there is
Okay.
whenever there is a insert, update, delete happens. Exclusive lock is nothing but it is a in the top level. Exclusive lock will be happen whenever you are doing that create table structure or altering the structure of the table. So that time it will happen the exclusive lock. Exclusive lock, no one can write it, read it, access it. Okay, everything it will be happen. Okay, every lock will be the access lock is nothing but for example, um, so you are loading the data into a data warehouse. Assume that on the Teradata, you are loading the data. So ETL process is loading the data. That means it is writing the data into the table. Before writing it, 7 o'clock it starts right, but 6:59 or 6:58, you want to read the data. Okay, you are reading the data for one reports. It is creating some arithmetic operations on the data or aggregate function is running, so it is taking some time. It is having billions of data. The reading is happening sometime. So at the same time, you want to write the data. Should I allow or I should not allow? You want to read the data. You are reading the data. At the same time, I'm going for writing the data into the table. Should I allow? So what will happen?
Should not.
What will happen? it will go for the queue. Okay, it will wait for the queue. Okay, if I'm reading the data,
Okay.
the right lock will allow you to go for the queue. So you should not allow, you should not, no need to go for the queue. Then you are thinking that, okay, I should not go for the queue. So for example, if the report is being generated on a table, I will apply some read lock. So why? Because I'm reading the data. At the same time, some ETL process is running, wants to write the data. So current day of the data, then it will wait for the queue. No need to wait for the queue. Instead of going for read lock, you can go for the access lock. You can go for the access lock. What will happen? So if you are placing access lock, the other user can write the data into the table. Got it? If you are going for
Okay.
access lock, the other user can write the data, but it
Then
will
how
not.
can we know which lock is presently in our
So by default,
table?
it will take care. By default, it will take care. If you want to downgrade or upgrade the locks, you have to exclusively go for the lock. So you can go for the access lock. So exclusive lock, it will automatically taken. Read and write lock, it will automatically taken. This access lock, we can go for. So you can go for read lock for this table. If you are making that table, the other user cannot write it at the same time. Instead of that, you are going for access lock. The other user can go for the write, but whatever the data you are seeing it might be inconsistency. Why? Because he may update it now. He may update it for current date data, right? But you are doing some millions of record on the data. Will be some changes will be there. Okay, for example, you have done access lock on the table. On very big table, you have done access lock. Like it has 5 years of data. You want to do some calculations on the 5 years transaction summary, something like balance you want to check or transaction amount you want to check. So today you are allowing that write operations. Why? Because it's access lock only, right? It will allow you to write into the table. Today's data alone it will write, right? So today's data alone it will be changed. So when compared to 5 years of aggregation, today's data will be very small. Am I correct? So compared to 5 years, today's data will be very small. So so this will be called as dirty lock. To overcome the waiting, access lock can be applied. So it will be dirty lock. Why? Because we are allowing other user to write it on the same time of reading. Clear? So you have to explicitly mention that. So there are the default lock will be there. Whenever if you are doing select operations on the table, there will be a read lock will be applied. The other user cannot read it. Okay. Whenever you are updating or inserting or deleting the record, write lock will be applied. The other user cannot write as well as read at the same time. Whenever you are doing create table operations, exclusive lock will be applied. Two users can do the access lock. So multiple users can do the access lock, no issues. These are all the default locks. Okay, default, by default it will take the access. So what are the 4 types of locks? I will tell you. First one, exclusive lock. So as I told, whenever you are doing the table creation, like creation, updation, creation, altering, whenever you are doing that DDL operations, so it will go for the exclusive lock. An exclusive lock restrict the access to the other object with any other user. It will not allow any other user. Okay, it will be exclusive lock. Write lock means other user cannot write it. So whenever you are going for insert, delete, update, the write lock will be applied on the object. So the other user cannot write and also cannot read. If the user wants to read the data, then you can go for the access lock. I told, right? You have to go for the access lock. So read and remember this, read and write will be incompatible with each other.
Can be performed.
Okay, it will be incompatible with each other. All other locks are held in queue until the write lock is released. So access lock. So access lock, I told it's a basic level of lock. We will say like it's a dirty read. Why? Because whatever the data inconsistency, right? So access lock are not concerned about the data consistency. So whatever the data is getting updated, no issues. You are seeing some data, I can say like, okay, no issues. I can see that unupdated data, no issues. Okay, yesterday's data I'm seeing it, no issues. Then I will go for the access log. That is called a dirty reads. So read log is nothing but, as I told, so read logs are used to ensure the consistency during the read operations. If I'm reading the data, at the same time other user cannot read it, then I can go for the read log. And the other user cannot write also. That is what read log will do that. For example, I said exclusive log prevent any other type of concurrent access. So it's a like top level access. If you put exclusive log, write operation, read
No one
operations,
can
access
write.
operation, everything will be locked. If you are going for write lock, okay, it will, the other user cannot read it, other user cannot write it, and also exclusive lock also, it will be waiting in the queue. Read operations, so other user cannot write it, and exclusive lock cannot do it. Okay, access lock I so told it's only for exclusive lock. So lock can be applied either in the database level, table level, or row level. So this is what the locking mechanism. For example, so consider this image. Consider this image. You are doing four access, like access exclusive lock, write lock, read lock, and access lock. This is lock level head. Whenever you are holding that none of the access on none of the lock has been hold. So can I do access lock? Yes, you can do access lock. Access lock will be granted. Can I do read lock? Yes. If none of the access on held it, then you can do that any operation. So exclusive lock also I can do it. For example, if I'm having access exclusive lock on the table, exclusive lock on the table. Okay. So can I do that? So you have done access lock. So something like access lock. Assume that I have done access lock on the table. If any exclusive lock is coming, it will be queued. Okay. So you can do that access lock. It's compatible. Read lock can be done. Write lock also can be done. If you are making like read lock, read at the same time, access can be done, read can be done. Other user can read the data, but other user cannot be write it. It will be on the queue. On the same way, the exclusive lock will be on the queue. If you are doing write lock, only access lock can be applied. Read and write lock, the other user cannot read it. Can be done right. Dirty reads. I told like it's a dirty reads.
Oh, dirty read. Oh, okay.
Okay, so if you are reading the data, if you are making like read lock, so other user can be doing some
During
read.
the access log, yeah, someone
They
can
can
read
use it.
while
Okay.
reading.
The write log is like if you have done write log on the object, the access log can be granted. Okay, it can be granted, but read log and write log exclusive log will be queued. So if you have done with exclusive lock, you have taken exclusive lock on the table, then all other operations should be queued. It should be, so you are creating the table. After creating the table only, or after altering the table only, any other the locks can be applied on the table. Okay. So you asked, right, how can I lock the table? You have to use this way. So whenever your session got completed, this lock will be automatically released. So locking row for access, locking table B for exclusive lock. So locking row for read. This is what you have to make. Okay, whenever you are writing query, right, you have to, if I want to do the read lock, then you can go for locking row for read. Select star from my table. So others cannot read it. So this will be maintained in the multiple user environment. In our environment, we cannot practice it. So because so multiple user environment, the other user cannot read it. If you go to any project, you can see this type of operations. Okay. So this will be a locking mechanism. So next one is like merge statement. So merge is nothing but whenever you are going for any ETL process, right? You will do the merge operation. Okay. So you have one table. Consider. So merge definitely you will use in real time. Okay. Merge operations. Remember the syntax. So you have one table here. You have another table here. So this is like work table. You assume that this is a work table. This is final table. It's a final table. So this work table structure is same with final table structure, provided the work table is having only today's record. The final table has some 10 years of data, or like 1 year of data, all the data to have. But the work table is having today's data only. So I'm having a record here. For example, 100 I'm having, 101 I'm having. So 102 I'm having, 103 I'm having. Like this I'm having first time. So I will check whether the 100 is present here. If it is not present, I will insert it. If not present, I will insert it. 101, 102, and 103, I will insert it. So if not present, I will insert it. So the next day you assume that the green color is next day. Okay, next day new data is coming. Okay, 104 is coming, 105 is coming. Some update is coming with 102. This is like update. Update is coming with 102. So what will happen? I will check this record is present or not. If not present, I will insert it. If not present, I will insert it. 105 also I will insert it. If I have some update on the record, I will go and update it in this record. I will check whether this record is present already. Yes, it is present. This record is already present. Some update is coming today. I will check this record is already present. Yes, if it is present, then I will update it. This is what the merge. You should not again insert it. Okay, why? Because it's a primary key column. You cannot insert it. We'll go for updated. So this is what merge operations will do. So merge operations. This is what will happen. So the syntax of the merge is merge into target table. Merge into target table. So using source table. Using source table, we are merging the target table in using source table on condition. So based on this condition, this common the key column condition, this employee ID or product ID equal to target product ID. So whenever there is a match, then only we are going for. So condition we are making it in the bracket. Condition when not matched, when the condition is not matched, then we are going for insert operation. Matched, when the matched, then we are going for update or delete. Okay, I will take the table called customer join. Okay, it has some customer data, right? Select from customer join 3. I will take. So it has some data. Assume that. Okay. I am going to create same table like this for merge table. So I will create two types of table, same like this table. Create table s underscore customer underscore merge as customer join 3. Okay, I'm creating that. I have created one more table. I'm creating with t underscore customer underscore with no data, comma primary index. What is the index field here? Customer ID, right? So I have created two tables. Now look at the table. Select star from this table. You have the table like this. Okay, I have 8 records. And this table I will not have any record. I will not have any record. So I'm going to write a merge statement. Okay, what is that merge? So merge into this one, target table, right? Target table. I will call this table as T. Okay, this table using source table as S. So BS on condition on S dot customer ID equal to T dot customer ID. When not matched, then insert. So you can directly insert values. Okay, values. While inserting it, you will insert all the record. Inserting it, you will insert with customer ID also. So s dot customer ID, comma start customer ID, s dot customer name, right? You have to use customer name, s dot mobile number, s dot email, comma s dot city ID. So this is what insert operations. Okay. Then update operations also you can go for. When matched, then you can go for update. So update set. Okay, set. No need to update the customer ID. Why? Because the customer ID only it's a common column. So you should not update the customer ID. You cannot update it. So s dot customer name. T dot customer name equal to s dot customer name. Whatever the T is having, right? T dot name equal to s dot name, comma T dot mobile number. MOB mobile number. T dot mobile number equal to s dot mobile number, comma T dot email equal to s dot email, comma T dot city ID to s dot city ID.
City.
So this is what you have to use it. So this is what the merge statement. Clear?
Okay.
Sometimes you will maintain the column name also. Insert column names values. Okay. So if I'm going for merging, it will merge 8 record into the table. Before merging, I will show you that it doesn't have any record, right? It will merge. So it will merging. See now. Target no need to mention. Why? Because here we have mentioned. Okay. Here, if you check the target table, the 8 rows will be merged. Okay. If again, if I'm going to execute, it will merge 8 record. Again, if I'm going to execute, again 8 record will be maintained, merged. It should not happen in real time. So for that, we are going for minus operations. If both are equal, you should not merge anything. For this, using this one as yes, right? So what we are going to do, minus operations, like select source minus target. If you are making this way, no record will be maintained, right? Select source minus target. If you are doing this way, select source minus target.
Select star from target minus.
No. Source minus target I'm doing. If you are doing source minus target and you have 8 record is there in the source, target also 8 record, you will not get any record, right? So if source is 9 record, target is 8 record. That means 1 record new. So that record alone we can go for the insert or update, right? Why do we need to go for all the record? So
Yes.
instead of going like this, we are going for minus operations. Then it will not merge anything. See now. So even though both are equal, before that it is merging, right? Now it will not merge anything. Merge completed 0 rows. If any record has been updated in source, for example, in the source I'm going to update record. Something like instead of Sri,
Customer.
I'm going to use another name. Customer name equal to John. I'm going to use it John
Name.
equal to Sri. So one row I'm going to update it. So this is only one row is updating, right? One row got updated. If you are doing this operation, it will do 8 rows merged. Okay. Instead of that, if I'm going to execute, for example, source minus target, that one row alone will be taken, right? Why? Because that is the one row is changed whenever you do source minus target. So if I'm go and update, so merge, it will do only one record, not all the record. So here, if I do this operation, it will do only one row merged. Instead of that, if I go for this one, if I'm not going this one, instead of this, if I'm going this way, 8 record will also merged. So for example, I'm going for some other, instead of updating one row, so previously I have executed this one, so one row processed. If I execute this one, all the 8 rows will be merged. See now. So that is why in real time we need to go for this type of query.